Hello friends, I welcome you in lecture number 29 on logic. In this lecture we are going to discuss another quantifier which is known as existential quantifier. In previous lecture number 28 we have discussed about universal quantifier, and we use universal quantifier whenever we want to denote that some property is true for all values of x in a given domain. But suppose we have this type of statement function. For example, suppose px is the statement function which is x plus 1 equal to 0, and suppose universe of discourse or domain is set of real numbers. Then we know that x plus 1 equal to 0 has solution x equal to minus 1, which is in the set of real numbers. So we can say that there exists a real number x, or there exists an x in the set of real numbers such that this statement function px is true. Or we can say that px is true for some x in the set of real numbers. Px is true for some x in the set of real numbers. So whenever we have this type of situation, we will use existential quantification of a given statement function. So again, if we consider px as x plus 1 equal to 0, and if I want to write down this in symbolic form, then we will use, for there exist, we will use this quantifier which is called existential quantifier. So we can write that there exists x such that px is true. So we will write either in this way, or some authors are using brackets also. There exists x in the bracket and px in the bracket, and the domain is set of real numbers. So we can say that if we consider this symbol existential quantifier, then this statement can be written in symbolic logic in this way. So whenever we have this type of situation that some statement function has truth value true for some element in the given domain, then we will use existential quantifier. So they can ask you to write down the definition also. We have to write systematically. Existential quantification of statement function px is the statement there exists an element x in the universe of discourse or domain such that px is true. And we will use this notation or this notation for the existential quantification of statement function px. This symbol is called existential quantifier, and whenever we write in this symbolic form, it means there is an x such that px is true, or we can write in this way also, there is at least one x such that px, or for some x px is true. So these are the different meanings of this symbolic form, that is existential quantification of px. So whenever we have this type of statements, we can write them in symbolic form using existential quantification, and similarly we can check the truth value of this existential quantification also. So this existential quantification is true if this statement function px is true for at least one value of x. As we have seen in the case of universal quantification, we know that this is universal quantification of statement function px, and this is true if this px is true for all values of x. And here in existential quantification, this quantification is true if there is at least one value of x for which px is true. That is the difference between these two, existential and universal quantification. So I have taken some examples to explain this concept of existential quantification. First example is, suppose px denote the statement function x is greater than 3. What is the truth value of the quantification? There exists x px where the universe of discourse consists of all real numbers. That is, domain under consideration is set of real numbers and statement function is given by px is x is greater than 3. And we have to check whether there exists x such that px is true, has truth value true or false. So here domain is the set of real numbers. So if we consider different values of x from the set of real numbers, we will have different statements. For example, if I consider x equal to 5, I will obtain p of 5, which is 5 is greater than 3, and this is always true. If I consider x equal to 1, then I will have p of 1 is 1 greater than 3, which is false. But for this existential quantification to be true, we require at least one x in the given domain such that this is correct. So we have obtained that for x equal to 5, this is correct. Therefore, this existential quantification is true. Similarly, you can write for another value of x also, but whenever they ask you to decide the truth value of the quantification or existential quantification, you have to find out at least one value of x for which given statement function is true. So here if we wish, we can consider x equal to 4 also. If I take x equal to 4, I will have 4 greater than 3, which is true. So we will mention at least one value of x for which px is true, and therefore this is having truth value true. So we will write systematically. Here statement function is x is greater than 3 and it is true when x equal to 4. We know that 4 is greater than 3 is true, or we can write in this way also, p of 4 is true. Therefore the existential quantification of px, which we have written as there exists x px, is true. So it is very easy to determine the truth value of existential quantification. You have to find the at least one value of variable x for which this is true, and if there does not exist any value of x for which px is true, then we can say that this existential quantification has truth value false. I have taken another example. Here qx denote the statement x equal to x plus 1. So first we write down given statement function, which is x equal to x plus 1, and universe of discourse consists of all real numbers, that is domain is the set of real numbers, and we have to find the truth value of the quantification. There exists x such that qx. Now first we check whether this is true or whether there is any x in the set of real numbers such that this happens. But it is obvious that this is not correct. If this is correct, then we will have x minus x equal to 1. That means x minus x is 0. So if 0 equal to 1, then this is correct. But this is not possible. This is a contradiction. Therefore, there is no real number x for which x equal to x plus 1. Therefore, this quantification is false because there is no x in the universe of discourse such that qx is true. So that I have written here. qx is false for every real number x, therefore there exists x qx is false. This is another example. What is the truth value of there exists x px? This we can read as existential quantification of px, where px is the statement x square greater than 10 and the universe of discourse consists of the positive integers not exceeding 4. That means the universe of discourse or the domain is positive integers not exceeding 4. That is, I have to consider first 4 positive integers, and px is the statement x square is greater than 10. Px is x square greater than 10, and I have to check the truth value, or I have to determine the truth value of this existential quantification. That means I have to find out at least one x from this for which this is true. So we can check one by one. Suppose I take x equal to 1, then I will have p of 1 is 1 square greater than 10. That is not correct. Suppose I consider x equal to 2, then I will have p of 2 is 2 square equal to 4, and that is also false. This is false. This is also false. Suppose I consider x equal to 3, then I have 3 square equal to 9 and is greater than 10. This is also false. But if I take x equal to 4, then I will have 4 square equal to 16, and that is greater than 10. So p of 4 has truth value true. So we can see that there is one x which is x equal to 4 in this domain of a given concept, such that px is true for that value of x. Therefore this truth value of this quantification is true. You can observe that we can write this as this: there exists x such that px. This is nothing but disjunction of these 4 statements, which are p of 1 or p of 2 or p of 3 or p of 4. If our domain is finite, then we can write this as the disjunction of 4 statements corresponding to 4 values of variable in the universe of discourse. And we know that disjunction is true if at least one variable has truth value true. Here p of 4 is true, therefore this is also true. So that we can write systematically. Here universe of discourse is 1, 2, 3, 4, and the statement there exists x px is the same as the disjunction p of 1, p of 2, p of 3, p of 4. Now p of 4 is 16 greater than 10, which is true, and therefore this is true because it is the disjunction of these 4. So in this way we can determine the truth values of existential quantification of a given statement function. I have taken this question on existential quantification, which was asked in GTU Summer 2022 exam. Here px is the statement x equal to x square, and the domain consists of the integers. That is, universe of discourse or domain is the set of integers, and statement px is x equal to x square. And using this information we have to determine the truth values of the following statements. First one is there exists x such that px. So we have to check whether there is any x in the set of integers for which x and x square are equal. So obviously if I take x equal to 1, then I will obtain 1 equal to 1 square, and we know that 1 square is 1. So this statement is true for x equal to 1, or we can say that p of 1 is true. And whenever we have existential quantification, we require at least one x such that given statement function is true. So therefore this is also true. Therefore there exists x such that px is true, because there is x equal to 1 in the domain such that it is true. Second one uses universal quantification of negation of px. Our px is x equal to x square. So if we take negation of px, then that is going to be x is not equal to x square. So here we have used universal quantification. So this means for every x, negation of px is true, and negation of px is x is not equal to x square. Now x is in the set of integers. So if I take x equal to 1, then I will have negation of p of 1 as 1 is not equal to 1 square, which is 1, and this is false. And we know that existential universal quantification of negation px is true if it is true, if this is true for all values of x, but there is some value of x which is x equal to 1 such that this is not true. Therefore this has truth value false. Therefore for every x, negation of px is false, because for x equal to 1, negation of px is not true. Next one is there exists x such that negation of px. Negation of px now is x is not equal to x square, and we have existential quantification. So we have to determine at least one value of x in the set of integers for which this is correct. So we can take x equal to 2. Suppose I take x equal to 2, I will have 2 here, and here 2 square, that is 4. So this is true for x equal to 2. Negation of px is true. Therefore this quantification, there exists x such that negation px is also true. This is true. So in this way we can determine the truth values of universal quantification or existential quantification. All we have to remember is that whenever we have this universal quantification, then this is true if px is true for all x, and whenever we have existential quantification, then this is true if there exists some x such that px is true for that x, for, or we can write px is true for some x, or if there exists at least one x such that px is true, then this is true. And whenever we have for all x px, then this is true whenever px is true for all values of x. Similarly, this is false if there exists some x such that px is not true, and this is false if for every x px is not true. So whenever we want to prove that this has truth value false, then we have to find out at least one value of x such that px is not true, and whenever we want to prove that this has truth value false, then we have to show that Px is not true for all values of x in the given domain. So this is all about this session. I hope you like it. Thanks for watching.